This video is made possible by my game bundle. Play 7 awesome games and help support the channel. Get the Steam game bundle at unitycodemonkey.com/gamebundle. In this video, we're going to take our DOTS Pathfinding code and apply it to the entity component system. So we have our entities, they add a component to request a path, and it's calculated using the super fast DOTS Pathfinding, and finally returned to the entity. Let's begin! Okay, so here is our goal. Over here I have a simple character and my map. Now I can right click anywhere in order to make areas walkable or unwalkable. And with the left click, there you go, the unit receives the order, calculates the path, and moves towards it. So if I try to go through a wall, there you go, it avoids the walls. And now here I've made the units roam around randomly, and by pressing a button, I can spawn some more units. Every time I press, there's 500 new units being spawned, and again, all of them moving randomly and calculating their path. So here in the stats, we can see the number of units. So right now, with 1,000 units, everything is running in about 4 to 5 milliseconds. So I can spawn a whole bunch more. Okay, so here we are at 10,000 units, all running pathfinding and roaming around randomly inside of this grid, and we're still managing to get it within 15 to 20 milliseconds. So that's an insane number of units, and just like that, you can see how insanely fast this works. And actually, most of the time that we're spending in here is working on the renderer and not actually on the pathfinding logic. So here in the profiler, looking at a single frame, you can see that the actual pathfinding is all the way in here. We have to zoom in, there you go, taking just 1 millisecond. And you can see over here a whole bunch of jobs, all of them running in parallel, all of them with burst enabled. So as you can see, most of the time that we're spending on a single frame is actually on rendering and not on the pathfinding, which is insanely fast. So if you had a better renderer, like for example the one I made where I managed to get 100,000 animated sprites at once, then you could push this a lot further. These DOTS videos take quite a lot of time to research and put together, so if you find the video helpful, consider supporting on Patreon or picking up the game bundle. So thank you to these awesome supporters for making this video possible. Go to patreon.com/unitycodemonkey to get some perks and help keep the videos free for everyone. Okay, so in the previous video, we implemented pathfinding using the other elements of the DOTS stack. We made it work with the job system and the burst compiler. Now here we want to make it work with the entity component system. Now if you haven't seen it yet, go watch that video and then come back to this one, check the link in the description. So here when I have my unit waiting around, he's just a simple sprite converted into an entity. So if we pause the game and look, yep, there you go, the unit is not on the scene as a game object, but rather as an entity. So if we look into the entity debugger, there it is. Over here we have the unit, and here in the inspector all of the components. So you can see, for example, the various pathfinding components that we're going to use in order to request a path and follow it. So here we have the path follow component as well as the path position, which is the dynamic buffer. So over here, as I click, it adds a component to the unit. Here you can see that it added the pathfinding params component. So this component contains the pathfinding information, so the start and end positions. And then the pathfinding system is looking for entities that have this component. When it finds one, it runs pathfinding with those parameters and places the resulting path back in the path position dynamic buffer. So over here you can see all of the positions in order to reach our target position. So there it is. Dynamic buffers are great, and if you want to learn more about them, check the video link in the description. So as I click, you can see the unit correctly following the path. Now, another very interesting thing that I have implemented here is the base for the pathfinding map and the visual. So here I'm using the grid that we made in a previous video, which is the same grid class that we used to create our object-oriented pathfinding. So the grid is composed of instances of this grid node class, and the visual is handled by this game object. So the very interesting thing here is how we're mixing game objects in the DOTS world into one single thing. I've seen a bunch of comments from people concerned that either you have to make your game completely with DOTS or completely with game objects, but the answer is you can mix and match. So you can use DOTS for whenever you need absolute performance, like for example pathfinding, and stick with game objects where performance is not an issue. So over here we have a practical example of that being used. Okay, so now that we've seen our goal and how we're going to reach it, let's actually implement it. Alright, here we are in our starting scene. Everything is working like in the previous video. So if you haven't seen that one yet, then go watch it and then come back here. That video covers implementing the A-star pathfinding algorithm using all the value types, so it works with the job system and the burst compiler. Okay, so how we're going to make it work with the entity component system is by adding a component with the path parameters. So let's begin by creating a new C# script. Call this our pathfinding params. So here it is, and now this will be a very simple struct, implement iComponentData. And inside we're going to have two fields. So we're going to have an int2 for the start position and an int2 for the end position. All right, so here we have a simple component that holds the parameters that we need to calculate our path. Okay, now let's see how we're going to add this to an entity. So let's make a system to listen to input so we can tell the unit where to move to. So here, let's create a new C# script, call this the unit move order system. And now in here, let's use Unity.entities. We're going to make this a component system. Now here, let's test for a simple input mouse button down. So when we press the left mouse button, let's pass in a pathfinding order. And for starters, let's just send them from a fixed position into another. So we do a entities.forEach. So we cycle through entities that have the translation component. And now in here, let's add our params component. All right, so there it is. When we press the left mouse button, we're going to add the component into our entity, and that component will contain a start position of 0, 0 going into 4, 0. All right, now let's go into the editor in order to make our entity. So here we are, and we're going to create a new 3D object, and let's make it a quad. And now in here, I have a basic texture, so just drag it. Yep, there you go, there's our unit. And to make it into an entity, all we need is to add the convert to entity script. And that's it. If you want to know more about converting and spawning entities, check out the video linked in the description. All right, so let's test. And yep, there you go. Over here in the corner on 0, 0, we have our entity. Okay, so we have our entity, and now let's click. And if we pause, over here, we can see that we do not have the unit game object. But if we look into the entity debugger, yep, there it is. Over here is our unit. And over here in the inspector, we can look and see that indeed we do have the pathfinding params component with a start on 0, 0 and an end on 4, 0. All right, so we have our entity receiving a component on click. Awesome. Now that we have this, let's run pathfinding based on these parameters. So over here is the pathfinding script that we made in the previous video. So we already have our find path job that has burst compile enabled. So now let's use this job with those pathfinding parameters. So first, let's go up here and convert this into a component system. All right, now on our update, let's do the usual entities for each. So we grab the entity and also the pathfinding params. So here we're cycling through every entity that contains a pathfinding params component. And now in here, let's create a job using these parameters. All right, so we instantiate a new instance of our job, pass in the parameters, and then we run the job. Now to see this working, let's just add a debug log. And after running our job, in order to make sure that the pathfinding only runs once for each entity, we can go into the post update commands and tell it to remove a component of type pathfinding params on this entity. So every time an entity receives a pathfinding params, it's going to run this code, it's going to calculate the path, and then remove the pathfinding params. So that's how we make sure that we find a path for a specific entity only once. All right, let's test. Okay, here we are with our entity idle, and we click. And yep, over here we can see that we are running our find path code and correctly calculating the exact path. So we have one right next to it. So we're going from 0, 0 to 1, 0, 2, 1, 3, 1, and finally 4, 0. All right, so our system is running and looking for a path as soon as the entity receives its parameters. So now that we have our parameters and path being calculated, let's see how we can make our unit follow it. Firstly, in order to store the path, we're going to use a dynamic buffer holding a list of int2 positions. If you're not familiar with dynamic buffers, check the video linked in the description. So let's make our buffer element. We create a new C# script, call this the path position. All right, here we have our buffer element data defined. All we have is really an int2 for the position of each path position. So now that we have our buffer element, let's make a authoring component so we can easily add it onto our entity. So back in the editor, let's create a new script, call it the path position authoring. All right, here's our authoring component. Again, if you're not familiar with the convert game object to entity, check out the videos on the dynamic buffer and on instantiating prefabs. So essentially this runs when we convert a game object onto an entity. So it calls this function with the created entity and the entity manager. And so in here we can simply add our buffer of path position. So now we can go back into the editor and over here select our entity. And all we need to do is drag the path position authoring component. So now if we test, and yep, the game is running, and over here on the entity debugger, we can select the unit, and there you go, indeed it does have a path position buffer. All right, so far so good. Now let's go into our pathfinding script. And in here we are cycling through our entity with the pathfinding params. And now let's also receive our dynamic buffer. So you grab it in here, and now let's also pass it down to the job. All right, so now the job receives a dynamic buffer. And now we can go all the way down here. After we calculate our current path, here we go. This is where we're actually generating the path. So previously, just for testing, we were creating a native list of into arrays. And now instead of doing that, we're going to add it directly onto the dynamic buffer. So here, let's do another version of this function. And instead, we're going to return void. And we receive the dynamic buffer. And yep, there it is. So we're doing pretty much the same logic as previously, except previously we were instantiating a new native list, and in here we're receiving the buffer, and we're directly adding the path positions onto our buffer. Okay, so now up here, let's use this function instead. All right, so just like that. And now again, since we're adding positions to the buffer, before we do this, let's make sure that we actually clear it. Okay. Right, so all this should be working. Let's test. Okay, here we are. There's the entity. Now we click. And now let's look into the entity debugger. And over here we have our entity. And yep, there you go. We have our path position buffer being correctly filled. So there you go. You can see going from 0, 0 to 1, 0 to 1, 3, 1, and finally 4, 0. So we have our dynamic buffer being correctly filled with the positions that were calculated. Awesome. Now that we have a path being calculated, let's make a system to actually follow it. So let's make a new script. Call this the path follow system. All right, we have our simple component system. Now here, let's cycle through the entities with dynamic buffer and the translation. All right, we are cycling through all the entities with the buffer and the translation. So now here we have a question. And the question is, how do we know which path position in the buffer should we actually follow? So should we go into index 0, index 1, or whatever? So to solve that, we need another component in order to keep track of the current path index that we're following. So for that, let's make a very simple script. Call this our path follow. All right, so here it is. We have a very basic component. All we have is an integer for the path index, and we're automatically generating the authoring component. So we can go into the editor, and here we select our unit, and let's drag the path follow component. There it is. And for default, let's set the path index to -1 to indicate that for starters we don't have a valid path. All right, so now let's go into the follow system. And now here we need the buffer, the translation, and also let's grab our path follow. And now if the path follow dot index, if the path index is actually valid, so more than 0, then let's grab the current path position. So we access the buffer on this index and we grab the position. And now we just do some simple code in order to move towards it. All right, so here it is, just some basic follow code. So you grab the path position, convert that into a float 3 for our target position. We calculate the move direction based on the target position and the current translation value. Define a certain move speed and simply move towards the move direction by the move speed multiplied by delta time. And finally, we check distance. If it's close enough, then we set to go into the next waypoint. And now if you remember, in the last video, when we calculated the path, we had the path actually reversed. So that's why here, when we reach the path position, we go into the next index, which is actually the one before. So we do index minus minus. Okay, so just like this, our system should be working. Now all we need to do is set up the path follow component. So let's go back into our pathfinding script and let's go down to the part where we are calculating the path. So here we calculate the path, which means that we are actually filling up the buffer. So we need to set the path follow component. For that, let's go up here in order to add another field. We're going to add a field of type component data from entity. of type path follow. Now here, if you're not familiar with this type, it essentially lets you access component data from a specific entity. So we're going to access this using the entity as the index. So for that, let's also grab the current entity. And now we can go down where we calculate our path. So here we are, we calculate the path. If we do not find something, then we access the component data from entity of this entity. And we set it to a new path follow, and we set the path index, in this case, to -1 because it's invalid. And down here, when the path is valid, we ask the position buffer in order to grab the length. All right, so there it is. Now we just need to pass this to the job. So let's go up here. When we're instantiating the job, we need to pass this. And now the way that we get this is by using the function get component data from entity and pass in our type. And we also need to pass in the entity. All right, that should do it. Let's test. Okay, here we are with the entity on the corner there. Now as I click, and there you go, the entity starts moving and follows the path correctly. Awesome. And right now, since the parameters are fixed, when I click, it goes back into 0, 0, and then follows the path in order to reach 4, 0. Okay, so over here, we already have quite a lot working. When we click, we add the pathfinding parameters. Then the pathfinding system listens to entities with pathfinding parameters and runs the pathfinding job to calculate the path. When the path is calculated, it gets added into a dynamic buffer. And lastly, the path follow system follows each path position in our buffer until it reaches the destination. Alright, so over here we have our unit correctly following the calculated path. Now you might have noticed that we still have one crucial thing missing here. Right now, our pathfinding grid is being completely created and instantiated over here as we begin our job. So we don't have a separate grid map working with our pathfinding. Now here, as you might have noticed, I set up this scene to use a grid, so I can right-click in order to make a certain position either walkable or not. So this is using the grid system that we created previously, as well as the visual. And over here, this is the script that is setting it up. So we create a pathfinding grid, which is a grid with instances of grid node. Here it is a grid node, as you can see, extremely simple. We just have an X, a Y, and a boolean for is walkable, very basic. So here we create the grid, and on right-click, I can set it to walkable or not. So here by right-clicking, there you go, the visual updates and says that something is walkable or not. But again, right now the job is creating its own grid. So for example, I can make this one visually blocked, but the pathfinding isn't connected to the grid at all. So as I click, there you go, he does not know there's a wall in there and just goes through it. Alright, so let's make the pathfinding grid be created and instantiated outside of the job. And here, this is also an excellent example of how you can mix Unity dots with regular game objects. So the grid in here is made using a class that is displayed using a game object. So if I pause, you can see that this is working on the pathfinding visual. So there it is, I can move it around. So what we're going to do is take this and convert it into a struct that we can then use with the pathfinding system. Again, the grid is set up in this class, where we have a static instance that we can use to access our public pathfinding grid. Alright, so let's go into the pathfinding system. And in here, let's make a function that will take the grid and convert it into a native array of these types of path nodes. So we're going to instantiate this right here. Alright, here it is. As you can see, we are building the native array, pretty much the same thing as we were doing previously down here. So we access the grid that we are using, and we simply cycle through the width and height and create a bunch of path nodes and place them in a flat native array. So you can see we're grabbing the isWalkable from the other grid that we created previously and that we're using as our base and as our visual. Now this returns a native array of path nodes, which is going to be our pathfinding grid map. So down here, now let's modify the job to receive the native array of our path nodes. And since this is a flat native array, we also need to receive a int2 for our grid size. And down here in the job, instead of creating the grid, all we need to do is set it up for starters. Alright, so there it is. Pretty much we're just calculating the age cost based on the end position that we receive in the job. Okay, so here we are creating our path node grid. And now let's go up here in order to pass it onto our job. So all we do is pass in the path node array, and we get the path node array. We also need the grid size. Alright, so here it is. Now we have set up everything. Now here just one more thing. since we are creating the path node array outside of it and then passing it into the job. Down here, previously we were calling path node array.dispose. Now instead of doing it in here, we can simply add the allocate on job completion. So that won't take care of deallocating the array. All right, let's test. Okay, so here we are. Now the start and end positions are still fixed, but we know he's going to go from this position over this position. So by default, it will go around this wall. So as I click, yep, there you go, goes around that wall and ends on the end position. Now let's place a bunch of more walls. So here I'm going to right click in order to modify the grid. And I'll click again, he goes back to the start, and now let's see, and yep, there you go. Now he correctly saw that these two are walls and he did not go through them. So the pathfinding grid that the job received is now correctly matching what we see in here. Awesome. Okay, now let's make it actually go to where we click. So here we are in the system where we're grabbing the mouse click. Now let's grab the mouse position and convert it into a grid position. Alright, so here it is. We're grabbing the mouse world position. We're using the CodeMonkey utilities, which as always you can grab for free from unitycodemonkey.com. Here is the function in case you want to implement it yourself. All it does is really just a world camera screen to world point. Alright, so we get the mouse world position. We get the cell size for the pathfinding grid. We get the X and Y position that matches the mouse world position. Then we just validate it to make sure that it's inside of the grid. So bigger than 0, smaller than width and height. So we do that to calculate the end position, and then we cycle through the entities, and we do the same thing to validate the starting position, and we add the pathfinding params component. Alright, so there it is, very simple. Let's test. Okay, so here we have our unit in the corner. Now let's put it in here and click, and there you go, the unit calculated the path and went exactly to the mouse position. So click again, and there you go. Now went from there to there, click, and there you go. Alright, awesome. So here we have the start and end positions correctly working. And again, we already made it work with walls, so let's right click, make a bunch of walls in here. And I'm gonna click for him to go in there, and yep, there you go. He goes around there, there, and there. All right, awesome. So we have our unit following the available path going from start to finish. Okay, so just like this, we have our pathfinding system working. We can add this pathfinding params component in order to set the pathfinding parameters. Then our pathfinding system looks for entities that contain the pathfinding parameters. When it finds those entities, it creates a pathfinding job. And finally, we have the path follow system, which looks for entities that have a valid path and simply makes them follow it. All right, so here we have a working system. However, there's still one thing missing, and it's actually one of the most important things. So right now, over here, we've been testing this with just a single unit. Obviously, we want our pathfinding code to be working nicely in parallel with multiple units. So here, let's just duplicate this object, and there you go, now we have 2 units. So here we are, and I click, and there you go, it does seem like it's still working. However, if we look in the profiler, and over here we can see the issue. So it is working, but you can see one path in here and one in here. So it's working, but it's working sequentially. So we have both jobs working on the main thread, and over here look at all of our job workers all completely idle. What we really want is to have them running the jobs in parallel. So back in the pathfinding script, now the way that we make them work in parallel is first we schedule all the jobs and then we tell them to complete them all. So in here, let's create a native list of job handle. So we create the list, then we add to the list our job. Instead of running it, we call schedule. And then down here, we use job handle and we call complete all. And we pass in our job handle list. All right, so that's it. First we schedule all the jobs and then we run them all in parallel. Let's test. So here we are and click, and there you go, we have found our error. It's essentially telling us that we cannot schedule 2 jobs that access the exact same data. So in this case, it's the component data from entity. Now this is the job system protecting us from causing race conditions. Over here we have multiple jobs all accessing this component data from entity, which is actually a native array. However, here we know what we're doing. We know that even though multiple jobs receive the same component data from entity, we know that each job will access this array with a different entity. So there's no actual race condition. So the solution here is to tell the compiler that we know exactly what we're doing and we want to disable safety. So for that, we go all the way up here in order to add another using unity.collections.lowlevel.unsafe. And inside of that namespace, Now we can add the attribute disable container safety restriction. So by adding this attribute, we're telling the compiler do not worry about safety when accessing this field. So now this won't correctly work. But again, be very careful when using these types of attributes. If you do end up with a race condition, your game will crash. So make sure your code is working perfectly before you start messing around with safety. Alright, so let's test. So here we are and click. And now here we have an error, although we did fix the other error. So we fixed the issue with concurrently accessing the component data from entity field. But now we have the same issue when accessing the dynamic buffer. So to verify that we fixed the issue, let's stop using the buffer. So here let's comment out everything related to the buffer. Okay, there it is. We are no longer using the buffer, so let's test. Here we are and click. And yep, there you go. The game is running and everything is correct. So we do not have any race conditions and there's no crash. Awesome. So now here when dealing with the dynamic buffer, it's something that I actually found quite strange. So you would assume that we could just add the exact same attribute in order to disable safety and be able to access the buffers in parallel. We can use something similar to the component data from entity by instead of using the dynamic buffer, we use buffer from entity. So we would assume that this would work. Again, we know we're never going to access the same buffer of the same entity in two jobs, so we know we're safe. However, just adding this attribute does not appear to disable safety. Over here, there we go, we still have our error. So I'm not sure if this is an issue specific with dynamic buffers that won't be fixed, or if dynamic buffers are special and somehow cannot be accessed in parallel at all. It seems like it should work just like this other one, but apparently it doesn't. I spent quite a long time looking into this and I could not find a solution to disable the safety completely. However, I did find another alternate solution that works well enough. So the solution is quite simple, which is just don't do it in parallel. So we can still calculate the path and get everything working correctly in parallel, and then we make a second type of job that will run just on the main thread and is solely responsible for filling up the buffers with the calculated path. Okay, so let's go all the way up here to make that secondary job. Okay, here it is, the set buffer path job. So here we just have the path node array, which after going through this job, the path node array has already been set up. So essentially all the path nodes already have the came from node index correctly set up. So we just use that in order to generate our path. And by doing that, we end up with the path position buffer correctly filled. So down here, let's get rid of all mentions of the buffer. So all of this will be done on the other job. And also here, make sure that we only deallocate the path node array after we set the buffer. So in this one, let's get rid of this attribute. Okay. And now up here, when we instantiate our jobs. So first we schedule all the jobs that do not use the buffer. We do all of those, we complete all of those, and after completing, then let's run the buffers while sequentially. Alright, so here it is. Over here, when we create our normal find path jobs, we're adding them into this basic list. So we instantiate them and put them inside of this list. And then in here, we just cycle through the list after the previous job has been completed. And we simply grab the data that we used on that same job in order to make this new job and fill up the correct buffers from entity. So again, I wish it were possible to make all of this inside of the other job. And I'm not sure if this is intended or a bug. But still, Unity DOTS is so fast that even with this part running on the main thread, it still ends up being insanely fast. Alright, so let's see it in action. Okay, so here we are and click, and there you go, both units calculate the path in parallel and they both go to the target position. And if we look into the profiler, over here in the profiler, you can now see indeed we have two worker threads correctly working on the find path job both in parallel. So now let's place some more units. So over here, let's just duplicate this one, place a bunch more. All right, we have a whole bunch of units and click, and yep, there you go. They all calculated the path and they all went straight to the target position. Awesome. Okay, so here we have our complete system working. We have multiple units working as entities, and we can click to set the parameters, which will then get calculated by the pathfinding system. So right now we can look into the profiler in order to test our speed. So just here in the code, in order to make sure that we test the pathfinding speed, we can simply comment out the post-update command in order to remove the pathfinding params. So this way, this component will not be removed, so it will be trying to look for paths on every single frame. So here we are in the profiler with 7 units looking for a path, and right now it's taking 1 millisecond, which is still quite a bit. And the reason is because we are missing our magic bullet, so that is the burst compiler. So just go over to Jobs, Burst, and Enable Burst Compilation, and let's test. And there you go, now here we have burst enabled, and look at that, the entire pathfinding is taking 0.37, and we have to zoom in real far in order to actually see our jobs working in parallel. So you can see all of them here in parallel, and then afterwards, we have in here the various jobs in order to set the buffer. So this is in parallel, and this is not, but it still ends up being insanely fast. Now let's try it with 100 units. Alright, so here we have 100 units. We can look into the stats in here to see the batch is 100. Yep, we got 100. And we click to enable pathfinding. And here in the profiler, you can indeed see a whole ton of find path jobs all working in parallel, all using burst. And then afterwards, all of the ones setting the buffer elements. So looking at the pathfinding, we have 100 units searching for a path, all in the exact same single frame, and it's taking just 4 milliseconds. So this is insanely fast. Alright, so over here I have set up the units to look for a random position, and when they get there, look for another random position. So as you can see, they are all roaming around very random. And over here on the stats, you can see just how quickly this code is running. So we have 1000 units randomly doing pathfinding in just 4 milliseconds. And again, I can modify the pathfinding grid by right-clicking. So let's put a wall in there. And yep, there you go, you can see them avoiding the positions with walls. And every time I press a button, I can spawn 500 units. So there you go, now we got 1500, and they all spawn over there on the corner. Now we got 2000. And again, everything's still running at about 5 to 6 milliseconds. Alright, so let's see how far we can push this. Okay, here we have 5000 running at about 10-12 milliseconds. And around 8000, we finally go under 60 FPS. And at 20,000, we are around 30 FPS. And this is all whilst I'm still recording the screen. So without that, it would go much further. So here we have 20,000 units randomly roaming around our level, and it's running at 30 frames per second. And really, half of that time is just spent on rendering. So we can look into the profiler. So here we have the profiler, and as you can see, for 20,000 units, all of our pathfinding is over here running in just 2.9 milliseconds. Then we have the path follow system in 0.7 milliseconds, and then a lot of the time is actually spent on rendering. So if we were using the rendering system that I made in a previous video, which supported over 100,000 animated sprites, by using that system we could push this even further. Alright, so here we have implemented A-star pathfinding in Unity DOTS. We're using the entirety of the DOTS stack, so we have the job system calculating paths in parallel, we have the burst compiler converting all of that code into super fast machine code, and we have our data-oriented entities running the logic and being displayed. So here it is, insanely fast, supporting tons of units. Alright, so this video and the previous one were quite tough to make, but I'm really happy with the results. Now with this working, I can start to work on making a simple RTS. Or maybe combine this with the DOTS physics in order to watch entities looking for paths and pushing each other around. Let me know what type of videos you'd like to see this system apply to. And also this took quite a long time to research and put together, so if you find the video helpful, consider supporting on Patreon or picking up the game bundle. So thank you to these awesome supporters for making this video possible. Go to patreon.com/UnityCodeMonkey to get some perks and help keep the videos free for everyone. As always, you can download the project files and utilities from UnityCodeMonkey.com. Subscribe to the channel for more Unity tutorials, post any questions you have in the comments, and I'll see you next time.